Dear students, under the topic graph theory, we are now going to learn about center of a tree. The first definition in order to learn about the center of a tree is we must know what is eccentricity of a graph. The eccentricity of a graph is defined as that is of any vertex v of a connected graph G is defined as which is denoted by E of V is equal to maximum of distance of the vertex V from any point U which belongs to the vertex set of the graph where this V will not be equal to U. So the eccentricity is denoted as E of V, and the eccentricity of any vertex V of a connected graph G is defined as the maximum distance of this vertex V from any point U of the graph G. So that is the longest path from V to any point is the eccentricity of a vertex in a graph G. So let us understand this with the help of an example now. Now here we consider an example. So this is a connected graph. So this graph is graph G. Now for this graph we have vertices, and let us find the eccentricity of each of the vertices for this graph G. So the eccentricity of the vertex V1. So first we will find that. So eccentricity of the vertex V1 is represented as E of V1, which is equal to, okay, that will be equal to, what is the definition actually? It is equal to the maximum of the distance of this V1 from other vertices of this graph. So let us, what is the distance of V1 from V2? The distance of the vertex V1 from V2 is the number of edges between these two vertices. That is, the number of edges in the path between these two vertices gives us the distance. Now the distance of V1 from V2, we have only one edge, so it is 1, comma, what is the next vertex in this graph? V3. What is the distance of V1 from V3? There are two edges between these two vertices, so in this path, so 1 2, so it is 2. And next vertex is V4, so 1 2 3, so there are three edges, so 3, comma, the next vertex is V5. So from V1 to V5 the path has 1 2 3 4, four vertices, four edges. And then from V4 1 to V6, so it is 1 2 3 4, so four edges. And then we have V7, the last vertex of this graph. So from V1 to V7 the path is V1 to V2, V2 to V7, and there are two edges, and so we have one more, that is 2. Now what is the maximum of all these values? The maximum of all these values is 4. So therefore the eccentricity of the vertex V1 for this graph is 4. Similarly, let us find the eccentricity of the vertex V2. So eccentricity of the vertex V2, which is equal to the maximum of, so what is the distance of V2 from V1? There is only one edge, so it is 1, comma, from V1 to V3 is 1. From V2 to V4 there are two edges. So from V2 to V5 there are 1 2 3, three edges. From V2 to V6 1 2 3, so there are three edges, and V2 to V7 one edge. So if you see what is the maximum of all these values, it is 3. So therefore the eccentricity of the vertex V2 is equal to 3. In a similar manner we have to calculate for V3. So what about the eccentricity of V3? It is the distance of V3 from the other vertices of G. So from V1 to V3 1 2. So maximum of 2, comma, from V3 to V2 is 1. One edge is only there. So then V3 to V4 is also one edge. Then V3 to V5 there are two edges. And then V3 to V6 again two edges, and V3 to V7 is also two edges. And finally we have the maximum of all these values to be equal to 2. So therefore the eccentricity of the vertex V3 is 2. In a similar manner, we will find the eccentricity of V4, V5, V6 and V7, and let me write in the same way. So I have calculated the eccentricity of the other remaining vertices also in the same way. You can do it by yourself and you can check. So these are the eccentricities of each of the vertices of this graph G. Now we shall move on to the next definition. The next definition that we are going to learn is radius. The radius of a connected graph G is defined by, that is, it is represented as r of G, which is the radius of G, and that is equal to minimum of all the values of the eccentricity of all the vertices of the graph G. So now if you see here in this example, we have found all the eccentricities of each of the vertices of this graph G. Now, out of all these values, what is the minimum that we have to find? So, the radius of the graph G is equal to minimum of all the eccentricity values of, that is, all the vertices we have to take, and for each of the vertices we have to find the eccentricities, and the minimum of those values will give us the radius. So what are the eccentricity values we have? It is 4, 3, 2. So let us write that 4, 3, 2, and then 3, 4, 4, 4. So 3, 4, 4, 4. So these are the eccentricities that we have found. Now what is the minimum of all these values? So if you see, the minimum value is 2. Therefore, the radius of the given graph is 2. So this is how we have to find the radius. So the next is the definition for central point. So which point is known as the central point for a graph? The vertex V of a connected graph G is called a central point of G if the eccentricity of V is equal to the radius of the graph. So if this coincides, then then V is said to be a central point. You can also say that the central point of the graph G is a vertex of G with minimum eccentricity. So which was the vertex that had minimum eccentricity? We have found the minimum eccentricity as 2, which was the radius. So which one gave us the minimum eccentricity of all these values? It was this vertex, that is vertex V3. Therefore, vertex V3 is the center point. Because we noticed that eccentricity of V3 was equal to the radius of the graph, which is equal to 2. So therefore, V3 is the central point. So this implies that V3 is the central point. So we have found the central point. The next definition that we are going to learn is center of a graph. So what is the definition for center of a graph G? The set of all central points of G is called the center of G. So it is also represented as C of G. Okay. So in this example, V3 was the central point. We had only one central point, but we can have more than one central point also. But here, since we had only one central point, the center of the graph G, which is represented as C of G, is equal to the singleton set V3, because it is the set. It is the set of all central points. Now, since the central point was only one, which is V3, the set of central point is V3, therefore which gives us the center of the graph. So this is the definition for center of a graph. So I hope you would have understood all these 4 definitions. So first we learnt about eccentricity, radius, and then central point. And using all these concepts, we have found the center of a graph G, which is represented as C of G. We will consider one more example in order to understand this better. Now here we have another example with 8 vertices. I will tell you why I considered this example at the end of this lecture. First of all, we will find the eccentricities. We have to find the center of this graph. Now in order to find the center of this graph, first what we need the eccentricities of each of the vertices. So for vertex V1, what will be the eccentricity? E of V1 is equal to the maximum of the distances of the point v1 from all the other vertices of this graph. So from v1 to v2 the distance is 2, I mean 1, because there is only one edge. Then v1 to v3 it is 2, since there is two edge. v1 to v4 is 3, 1 2 3, three edges between them. v1 to v5 is 4, because 1 2 3 4, four edges between them. And then v1 to v6 we have 1 2 3 4 5 edges. So v1 to v7 also 5 edges. Then v1 to v8 2 edges. So if we see like that, what is the maximum value? It is 1 2 3 4 5. Here also 1 2 3 4 5. So 5 is the maximum value, and so the eccentricity of v1 is 5. And then what about the eccentricity of v2? It is equal to, what is the maximum distance of v2 from other vertices? So here it is 1, here also 1, here 1. From this point it is, for to this point it is 2, to v5 it is 3, to v6 it is 4. So therefore it is 4, and for v7 also 4. So it is 4. Similarly, the eccentricity of v3 we will write, which is equal to, now this is v3. From v1 to v3 we have two edges, and then from v2 to v3 one edge, v8 to v3 two edges, v3 to v4 one edge, v3 to v5 two edges, v3 to v6 three edges, because 1 2 3, v3 to v7 three edges. So which was maximum distance? 3. So E of v3 is equal to 3. What about E of v4? It is equal to, so from v1 to v4 it is 3, 1 2 3, v8 to v4 also 3, v2 to v4 2, v3 to v4 1, v4 to v5 1, v4 to v6 2, v4 to v7 2. So what was the maximum from v1 to v4 and v8 to v4, which was 1 2 3. So E of v4 is equal to 3. Then similarly we will find for the other vertices, and let me write. So I have found the eccentricities of other vertices and I have written overall. Now what about the radius of the graph G? It is the minimum of all the eccentricities that we have found. So 5 4 4 5 and 3 3 5 5. So if you see, minimum value is 3, and so therefore the radius of the graph is 3. Then we have to find the center. So what are the central points we have to see? Which one contributed 3 for us? These two vertices, V3 and V4. So these are the central points, because for these 2 points only, eccentricity of V3 is equal to 3, which is equal to the radius of the graph. Similarly, eccentricity of V4 is equal to 3, which is equal to the radius of the graph. So E of V3 is equal to R of G, and E of V4 is equal to R of G, which means there are two central points for this graph. In our previous example, there was only one central point. Now for this graph, there are two central points, because for two vertices, the radius, that is the eccentricity values, are 3, which is the radius, that is the minimum of all the eccentricities. For that reason only I chose this example, in order to show you that here there are two vertices, and therefore the center of the graph will be that is C of G, which is equal to the set of all central points. So what are the central points? V3, V4. Therefore V3, V4 are the vertices, that is the set of all central points gives us the center of G. In our previous example, there was only one point, because there is only one element in C of G, because only one central point we had. Now here in this example, we have two central points. Therefore, C of G is equal to V3, V4. With the help of these two examples, we can also understand that whenever the length of the longest path is even, there will be only one central point. And whenever the length of the longest path is odd, there will be two central points. For that reason, here I will show you what is the length of the longest path in this. Okay, that is the longest path is from V1 to V5, which is 1, 2, 3, 4. So length of the longest path is 4, which is even. So if it is even, then for such a graph, there will be only one central point. And if you see for this graph, it is only one central point, which is V3. So this is the central point of the graph. Whenever the length of the longest path is odd, so if you see here, this is the graph that we have, and the length of the longest path is odd for this, because from V1 to V6 gives us the longest path 1 2 3 4 5, and the length is 5. So whenever it is odd, then the number of central points, that is the center of G, will have 2 points. So two points which will be adjacent to one another also. So if you see, V3 and V4 are adjacent. So this is a central point and this is a central point. Now this concept we are going to prove as a theorem now. So the theorem statement is, every tree has a center consisting of one point or two adjacent points. We just now saw an example, two examples where the center was 1 point for one example, and another example there were two center points which were adjacent to one another. Kindly follow the upcoming video lecture in order to understand this theorem. Thank you.